Hey, Dominic. Good morning, and good morning to Noah and Merla. Thanks for showing up. Here's some more. Lee's here and Natalie. As well as Isabella. Appreciate you coming to the live stream. Let's see if a few more show up. Our goal today, our objective is to talk about forces on skiers and solve to get some of those forces as well. Riley's here. As is Sarah. We've reached a third of our number. That's nice. See if we get a few more. Oh, now we get a bunch. Hello to Larissa and Lily and Nicholas. Hello to Julian K. Hello to Tom and Lena. And thanks for joining us. While we're gathering up, I'll wait another minute or two, but do you have any questions about the MSA? It is next week, your presentation. By now, you probably sent or are sending the information to your two or three people, usually it's three, that are going to come and watch you do your presentation. So if you've got some questions, ask me now. Hello, Shilpa. Hey, 15, we're 2/3 of the way there. Let's see if we get a few others before we start up. Again, our objective is forces on skiers today. We'll start that in just a moment. All right, then let's move over here and begin. I've got you sitting on top of an OB plastic bucket. So you're a little higher than normal so you can see the board. And I'm in here because I got meetings today. Next week, I may not meet with you at all because A, I want to give you time to deal with your MSA, and B, I've got to watch some as well myself. And there's another person here too. There is Magdalena. So, good morning. No MSA questions. Okay, well, I'll appreciate it. Then if you're set, that's okay. All right, so recall last time we had a skier on the flats. You have this picture already, okay? I know that. So here's the flats, and here's your skier. And the skier, I'm going to use some specific colors today. Let's use green for gravity. So one force we had on the skier in the middle of, let's say it's a young 8th grade girl. So there's the force of gravity going down. And if she's not moving, which she's not if she's on the flats, in my picture, what force is going the other way? So let's see if you can look back in your notes and find it. If the force of gravity is pulling her down, what's the force pulling her up or pushing her up? I'm going to draw that while you think about it. See if you can type that in. Actually, I want to pause a second. Riley's got it. The normal force, Sarah too. Good. And it should be, of course, how long compared to the gravitational force? And if you said the same, you're right. Now they're in different directions. One's going up, one's going down, but they're both going to be 500 newtons. Why? Because that's what we picked. Equal, equal, equal. Thank you. Oh, Vincent is here too. Got to say hi, Vincent, so I know you're there. Anybody else newly arrived? Okay, it's 500 newtons because that's what we agreed last time was the weight of our young skier. So the force of gravity is 500 newtons. Okay, here, force of gravity equals the force of that, although we might want to say it's the opposite of that. Negative. But that's more advanced than I need you to worry about. Okay, they're the same amount. They're 500 newtons. Yeah? Okie dokie. Yeah, good. Okay, let's put the skier today on a slope. So we're going to put her first on a beginner slope. And let's say that that slope is forces on a beginning skier with 500 Newton weight. Now remember, you might measure your weight in kilos, but really weight in a physics language is in newtons. So we agreed last time she's a 500 Newton young person. Okay, let's put her on a slope. Ready? Here we go. So let's say that this angle to the horizontal is 30 degrees. Let's make it 30.0 for fun, okay? So mark your little angle, and now let's put a skier on here. So here she is, the same person. Actually, I should make the skis turned up, right? And there she is. She's moving a little bit down slope. Now we're going to ignore friction, okay? But we are going to have some other forces going on. Okay. I've still got her force of gravity, don't I? And which way is that going, her force of gravity? Where should I draw that on her? This is, by the way, called a free body diagram. So we're going to kind of show her and show straight down. Thank you, Larissa. Thank you, Magdalena. So I'm going to make it the same as the other picture. In other words, she's the same person. It better still be 500 newtons, okay? So, okay. So there she's going. So her force of gravity is still 500 newtons. Okay. Now, I used, thank you. A lot of people responded to that. Appreciate it. I used yellow for the normal force, and I wish you could point in the air, but I can't see your fingers, so I can't see which way you're pointing. Remember last time we said the normal force is always perpendicular to the what? What's the normal force perpendicular to? Because we got to do that in this picture as well. I'm going to do that in yellow. The normal force is perpendicular to what? To the surface. Good. So, ready? Here we go. I got to go perpendicular, so I got to go right through her middle of her head. Another name for the normal force is called the support force. Now, she's on a 30-degree slope now. Will her support force be as big? What do you think? Yes or no? She's on a 30-degree slope. Will her support force be as big as before, her normal force? And if not, which way will it be? Okay, Priya's here. Thank you, Priya. No is correct. And so how is it? It's not the same as before. Is it more or less? Here's the support force. That's what's keeping her up. So if she's on the flats, then I got to push up with the mass of her, with the strength of her weight, 500 newtons. But if she's on a slope, I will be able to provide, yes, now you got it. Thank you, all of you, less support. So I got to make the arrow less long. Watch this. So I'm going to make it from here, middle of her person, out a little ways, and then I'm going to stop. So there's a third force, and the third force is taking her down the slope. I'm going to call that the sliding force. So I'm going to put a little arrow. Now she's sliding directly down here. So I'm going to put that parallel to the slope. You ready? All right. So I'm going to call that F of sliding. And the other one in yellow is still F of N. Okay, I hope you have that triangle because we've got to now use that triangle. And Deacon has joined us. We've got to use that triangle to make something more intricate and more useful. So that's a free body diagram. Okay? Free body diagram. What we're going to do now is we're going to make what's called a force triangle. So here's what we're going to do. So use a force triangle to find her F of N and F of SL. SL for sliding. Okay? Slide. I'll just write the word one last time. Okay? Here we go. Force triangles are tricky. Okay. We're going to make a triangle like in math class. Which force is the greatest? Which one is the longest in the diagram I just did with you? Or another way to say it is, which is going to be the longest side of our triangle? The hypotenuse. Force normal, force sliding, or force of gravity? Which is the longest side? What will be the longest side in our hypotenuse? Gravity. Thank you. That is right. So here we go. Take it. Ready? What? And put it over here. I'm going to put it on the board. So there's my F and G. I'm using the same color over and over, green, so I can see that. Good. Now we're going to put the other forces in. I'm going to show you how to do it because this is your first one that you've done. Okay. We're going to take this one off now. And we're going to have it go like this. Ready? Take the normal force. Grab it with your fingers. What? I'm going to put it right here. What? And turns out I probably didn't draw it very well. Because if I draw it correctly, the angle right here, believe it or not, should be the same as the angle of my slope. So my slope was 30 degrees. This angle at the top needs to also be 30 degrees. So I'm going to readjust my drawing over here. I probably should have that a bit longer. But that's what we do. We make mistakes and we try and fix them. The third side is going to be the third side of our triangle. You ready? And it's going to be, see how it's perpendicular here to the force normal? It's going to be that way in our triangle too. Ready? Grab that sucker. Here comes the force of sliding. And the force of sliding is going this way. The force of normal is going this way. The gravity, of course, is going down. And show that that's perpendicular, right? So this is a right angle, and so is this. Hey, we got a right triangle. Ah, how beautiful is that? So physics loves right triangles because we can use trigonometry and solve for all sorts of cool stuff. Let's label the three sides. Yes, I know it's a weird thing because it's not like you think. It's not sitting pretty. It's perpendicular because, sorry, it's pointing down. That's its longest side because that's pointed down in the real world, gravity towards the center of the earth. So it's got to be pointed straight down. The other two are what they are. The normal force meets the gravitational force up at the top, force normal, and the FSL, sliding force, is this one down here. Okay? Here's the cool thing. We know one of those sides. Which one do we know? Which side do we know? Thank you, Larissa. And Lou. Okay. We know force of gravity, and that sucker is 500 newtons. Let's call it 500 points, and we get 3 sig figs out of it, okay? 500 newtons, that's her weight in newtons. And so that's that side of the triangle. Hey, suddenly all this is possible. Let's find ba-ba and ba-ba. Tell you what, let's find the sliding friction first for grams. So F of SL. Okay, well, stand here at the angle you know. Really, you know all three, but I'm going to stand here at this angle, and I'm going to look over, and I know this side, that's the hypotenuse, and the FSL is the what? That's the opposite. So if I stand here, then the bottom here is FSL, the force of sliding, divided by the hypotenuse, F of G, and that, you know, people, is the of 30 degrees. So what trigonometry is that? What trigonometric function is that? So you're standing here, it's this side over the hypotenuse. This side over the hypotenuse, okay? If I stand there at 30, what is that? That's the of 30 degrees. And I got a couple answers, and they're all right. Thank you, Merla and Sarah and Lily and Shilpa and Lee. Good. So it's sine. So the sine of 30. So I'm going to ask you to run around your bedroom or kitchen or wherever and find your calculator. Okay? Go get your calculator. Put it on degrees, not on radians. So please go get your calculator. Or use one if you got one on your laptop, or you can pull one off the internet. Well, let's put in what we know here, right? So sine of 30 equals FSL divided by, well, we know what this is. It's 500 newtons. Hey, suddenly you can do this, right? So we're going to solve it, and I bet you know, multiply both sides times 500 newtons. So I'm going to get 500 newtons times sine of 30. And that's my F of sliding. Could you guys all punch that out and round your answer and let me know what you get, please? So please find the answer for me. What's the force of sliding for our young skier? And I got a couple guesses of 250. That looks cool. And that makes sense because sine of 30 is a half, isn't it? So it'd be what? It'd be 250 newtons. Nice. You're halfway there. Good. Everybody got the same thing, including Magdalene and Isabella. Appreciate you doing that. Let's answer the other question, okay? Let's answer, what color did I use? How about yellow? What's the force in normal? Now, We could use Pythagorean theorem, but let's use trig because it's fun to use trig. So we want the force of normal. So we want equals. Okay, if I'm standing here, then I can put the normal force over F of G. And that's the of 30 degrees. That's the of 30 degrees. So here you are, over 30. So this side over 30, also called the adjacent side over the hypotenuse. That is which trigonometric function? Several of you have it. Larissa and Lee are on the ball. Let's see if anybody else comes up with it. It is indeed cosine. Remember, SOHCAHTOA. Ka, adjacent over hypotenuse. SOHCAHTOA, cosine. Let's put in some substitutes and numbers and get an answer. Ready? So cosine 30. Equals Fn over, well, it's still the same person, 500 newtons is her weight. So I can still do this. And then we can solve for it. So go ahead and do that. In fact, can I just jump to the chase, people? Can you solve for that and give me an answer? So what's the force of normal for this young skier? What's her normal force? I'll wait for your answer. And Shilpa got 433, as did Lee and Larissa and Natalie. Thank you. And notice they don't add up to 500, do they? Because it's not adding, it's a Pythagorean theorem type thing. Okay, so at any rate, yeah, okay, so she has a support force, but it's not as much as when she was on the flats. Then it was 500, just like this. Now it's a bit less, 433. But you know what? It's not that much because the slope's fairly gentle. Why? Because a lot of you were with me on the 8th grade ski trip, and you know I don't want to kill my young skiers. But now, after a week, you guys know how to ski. So we're going to take you on the advanced slope, okay? Questions before we do that? So we're going to get the forces on an advanced skier. Let's say it's our same young person. Same young person. Okay, then we're going to put her on a bigger slope. Let's put her on something steep. Let's put her on this. Ready? Before we did 30, let's do 75. Whoa, 75 degrees. Holy smokes. She better be advanced. That's a pretty good slope. Let's draw her on there. So down she goes. There she is. Got her helmet on. And she's flying. So put some motion lines on her. Okay, even though she's still on there, she's still got the same force. Still got the same force. So let's put that on her. Force of gravity. Thank you, Larissa. Great. What about her normal force? Her normal force is going to be more or less than the gentle slope. How will her normal force be now compared to the gentle slope, or Fn. Less is right. I like the way you added the second S, Larissa. Okay, so here we go. And it's perpendicular to the slope. Look at this. So it's going through her head. Probably not a lot. So there's the force normal. There's the force G. And we got a big force going down the slope. And that's going to be now parallel to the slope. And that's going to be the sliding. So make your sliding parallel to the mountain. The perpendicular will be the normal. That's the normal is perpendicular to the mountain, to the surface. And then the apogee goes straight down towards the center of the earth still. Good. We're going to ask the same question. So find F of sliding and F of normal. Order. Okay, force triangle. Force triangle. Begin with your longest side. My longest side is what? My longest side is what force? Thank you, Lee and Magdalena. Now, some people, when I've taught this course, say, "No, but Mr. Weiss, I'm flying, man. My sliding force has got to be bigger than that." Well, the only time your sliding force is bigger is if you're free falling, and someone's pushing you at the same time, which doesn't happen very often, okay? So unless you're falling through the air and someone's also pushing you, your sliding force is not going to be bigger than your gravitational force. So I still got the same F of G going down. I'm going to make it a little bigger just so you can see this, okay? So there's F of G. And where's the other triangle? There it is. Okay, so my F of G is still going to be 500. And let's put on the other ones. You ready? Let's look at our other triangle. The normal was like this. Now my normal is, whoa, it's like that. But I still put it at the top of the triangle. Is that weird? You betcha it's weird. So it's kind of like this. Or maybe even more so. Because that F of normal has got to be right here. It's got to make an angle. And I know this is strange. It's got to make the same angle that she had on her slope, which is 75 degrees. And now the force is sliding. Ready? I got to make this a right angle. That's actually pretty good. That's actually pretty good. However, on my drawing, I might want to make it a little longer because it's almost as long as gravity. It's really a lot of sliding force. At any rate, you get the idea. Maybe my Fn should be a little smaller, maybe. I don't know. On my original diagram. But that, my folks, is one of the hardest things you'll do all year. So making a force triangle. Why? Because the angle starts here, but it ends up at the top of the triangle. It's weird. Okay, let's go ahead and solve before we run out of time. So let's get the F of, I don't know, sliding first. Same as before, same as before. I'm standing here, so the of 75 is FSL. Force of sliding over the force normal, force of gravity, pardon me. And that's the of 75.0 degrees. And of course, if I'm there, it's just like before, isn't it? Opposite. Opposite side over the hypotenuse is the sine. So solve for that, would you? So F of SL simply equals sine of 75.0 degrees times the force of gravity. But I know what that is. That's 500 newtons. So I'm just going to move that over. And at the very same, so you guys can solve for that. See what that is. You guys are so quick. You're way ahead of me. So it's 483 by the looks of it. Okay, do it as quick as you can. Do the other side too. So I've got force of normal. Let's find out. So force of normal over the force of gravity. And that better still equal cosine 75 degrees. And of course, you're going to beat me, I know, because you guys are good. You have to write in different colors. So it's going to be cos 75 times 500 newtons. And I knew it. Look at that. Somebody beat me already. Lily beat me. Let's see if some others get the same answer for the force of normal. The force of normal. See what if you get the same thing as Lily. You did. You all got the same thing. There's a little rounding difference, but that's okay. I'll say 129. Now think about that, all right? She weighs 500 newtons as a weight, and the poor young skier, she's only got 129 newtons of that supported by the slope. Man, she's flying. No wonder she's flying. Look at that's a big percentage, isn't it, of her force of gravity? Her force of gravity is 500. That's 483. Oh, she's almost free falling, right? Of course, if she's free falling, that would be at what degree slope? You can free fall while you're skiing. I don't recommend it. Although if you've done a jump, you're free falling while you're jumping. But all right, that's a little. Yeah, thank you, Nicholas. 90-degree slope. So yeah, okay. So that's the scoop. You guys did well with that, I gotta say. It's not easy, but notice that the normal and the gravitational forces always meet at the top of that force triangle. Do they do this in every sort of force? Turns out the answer is no. Do I have time to show you one other? I guess I will. Do you have questions before I erase all this? I'll erase some of this. If you understand that, you're going to be set for forces with Leistner's course physics or Grundkurs or AP physics with Mr. Blessman. So if you like any of this physics stuff, take more physics, please, and you're going to be ready for some forces. Ute. Here's one last force, and it goes like this. Ah! Okay. Oh, man. Okay. Feel my neck. If I hold this bucket straight down, I'm sorry, you got to see this. If I hold this bucket straight down, it's not such a big deal, right? But what if I hold it at 45 degrees? Will it take me more or less force? Yes, it does point down always. Thank you, Magdalena. Good question. So I call this the tensional force. And it's right, it's more. Thank you, Larissa. So if I hold it straight down, it's not so bad. But if I hold it out here, that's kind of a lot. So we're going to make a quick diagram about that. It's called the tension force. I'm just going to draw my arm. And here's the bucket. And let's say then this bucket is, let's say it's like 20 newtons, which might be about right. And my question is, what's the force of tension? There's my hand. What tension is on Mr. Weiss's arm? Well, the answer is, I don't have to worry about my weight, and it turns out the force triangle for this one is really easy. You ready? Here we go. Straight down is the force of gravity of this sucker. That's F of G. I'll do that in green again. I'll do it bigger too. So F of G is 20.0 newtons. Okay? The tension of force is right here. And turns out, Larissa's right, and others too. It's more. It's the longest side of the triangle. It's longer than F of G. So that's the hypotenuse. So that sucker, at the tension, that's the hypotenuse. And it turns out the angle is the same as I had here. Remember I said it's going to be 45? So let it be 45. And suddenly I got a right triangle. The third force is just called F of X. We don't have to worry about it. It's like the force you pull out in the X direction, but I don't really care about that. So let's find the tension of force on my arm before we go. We've got just enough time. So here we go. This is the hypotenuse now, and all I need is to stand here and ask you the same question. So I could put the force of gravity this time. That's the adjacent side. Adjacent over the force of tension, F of T it's called. Well, I'll say tension. And that's the hypotenuse. And that's the which trig function again. Can you guys just punch it in there so I know you're still with me? So the adjacent over the hypotenuse is the of 45 degrees. So the adjacent over the hypotenuse, adjacent hypotenuse, is the of 45 degrees. What's the trigonometric function? I'm getting better at saying that. One person's got it. And another, Larissa, Shopa, Magdalena, thank you. It is indeed the cosine, so katoa, adjacent over hypotenuse. So cosine of that. And we still got it. Look at this. We can still get this answer. This time I know the F of G, it's on top, is 20.0 newtons. And I got an FT on the bottom. And it equals sine of 40, or cosine 45. So do you remember my trick? Remember my trick I taught you? If something's on the top of one side, on the bottom of the other, without any other terms, you can just switch them. So it turns out I can say F of T, the tensional force equals 20.0 newtons divided by cosine of 45. I'm hurrying, so I'll worry about sig figs at the end. So could you solve that now? So what is the tensional force on my arm if I don't hold it straight down, but hold it at an angle of 45? And Lily's got it already. Super, 28 newtons. So, no wonder it feels like more. So if I hold it straight down, that's easier. If I have to hold it at an angle, it's harder because it's more force. 20 straight down, 28 when I hold it over here. And you know what? I can really feel it. And frankly, if I hold it at a greater angle, ow, it's probably more. Probably more. But you could work that out yourself. Well done, gang. I'm going to stop right there and see if you have any questions on forces. I threw a lot at you. I know. That's two types of force problems, and it's the two major types of force problems: tensional force, and the other one is things on a slope. Okay, forces on a slope. That covers a lot in physics. Yeah? Okay. Unless you have any other MSA questions, I'm going to just call it good for this hour. And I don't know if I'll have another assignment for you. We're supposed to give you guys lots of time to work and practice your MSAs. I want you all to do well. And so I may not even meet with you next week because I got something at school Monday, Tuesday, Wednesday, Thursday anyway. And so I probably can't meet with you guys anyway. So I'm going to wish you luck on your MSAs. Write me if you got any questions about the or about physics. Okay? And after break, we'll start chemistry. Yoo-hoo! Because I love chem. So chem is going to be way fun. I haven't taught 10th grade in 2 years, so that'll be kind of cool. Okay, I'm done jabbering. Goodbye, everybody. Stay healthy.